Hi my friends, let's model the part number 35 valve body from my collection of 100 parts. You are noticed that the part 34 was presented in my first tutorial in this series. Let's take a look to the drawing. This is the part. I can show you as a picture. It has a hollow part inside, a thread here, and two flanges, round and square. Let's see the drawing again to analyze a little. There is a vertical revolve feature and two horizontal. Yes, we start with this flange at the bottom, then we create this vertical, then the others, and the last are the hollows. Yes, because you can subtract volumes only after every external features are created. Yes, you don't start with revolving external and internal, and then how to connect the internal hollow features. There is a procedure here. I see in other tutorials how they create a lot of things one over other, and then erase surfaces or something like this. No, I try to respect a good procedure from my experience. Okay, let's create the first flange, which is presented here with four corners rounded at radius 10 on a circle of 70 millimeter diameter. And now you know that X must be on the horizontal. And then, hi my friends, let's model the part number 35 valve body from my collection of 100 parts. You are noticed that the part 34 was presented in my first tutorial in this series. Let's take a look to the drawing. This is the part. I can show you as a picture. It has a hollow part inside, a thread here, and two flanges, round and square. Let's see the drawing again to analyze a little. There is a vertical revolve feature and 2 horizontal. Yes, we start with this flange at the bottom, then we create this vertical, then the others, and the last are the hollows. Yes, because you can subtract volumes only after every external features are created. Yes, you don't start with revolving external and internal, and then how to connect the internal hollow features. There is a procedure here. I see in other tutorials how they create a lot of things one over other, and then erase surfaces or something like this. No, I try to respect a good procedure from my experience. Okay, let's create the first flange, which is presented here with 4 corners rounded at radius 10 on a circle of 70 millimeter diameter. And now you know that X must be on the horizontal, and then I select a centered rectangle with the center here, a dimension is this and the other is here. I make vertical this one equal to sides, and now what dimensions are needed? Only one. This one is the diagonal of 70. Yes? Okay. Now I apply offset. I look here to see the radius is 10. Okay, then offset of 10. All this line are to be construction lines. Now fillet of 10 to every corner. This one and all the other. Fully constrained. The sketch is finished. F6. What is the thickness? The thickness is 10, which is by default for extrude. Okay. The next, as I said, is the vertical external revolved body. What is the construction? 1 line, 2, 3. Yes, and this must be the base for revolving. A diameter of 30, a diameter of 40, a height of 115, and another dimension of 25. 5. Remember this. I select this or this plane. I prefer XY, and then F7. I draw 3 lines, 1, 2, 3, and closing. Yes, this one is to be center line, and then dimensions from here to the center point. It is 115. This diameter is 30. The other is 40. And the last is 25. This is 25. Okay. Finish the sketch. Revolve. Okay. Next is this horizontal revolving, which is oriented to the left button. Then we choose this axis, the plane which contains this axis. This is the plane. Sketch. F7 to see inside. And now we draw this contour with the dimensions here G3/4. What is this? Well, you have to know this. In our tutorial number 20, I explained all these things, but I'll repeat now for you to be very sure of what you do. I have to know what is this diameter. Yes, this is why, as I presented in the tutorial number 20, there is a link in your computer with this long path to go to this Microsoft Office Excel file. Double click on it. I write also in the description this link to can copy paste in your file explorer. This is the file explorer. Yes, double click on this and we can see all definitions for threads. DIN pipe, BSP. This is what I select because this is British standard and they invented the gauze fillet. And you see here the thread designation, which for 3/4 is this line, and the major diameter is 26,441. Yes, with the pitch, diameter and minor diameter and everything you want. I refer to an external thread like ours. Yes? Remember this, I copy to have no problem. I copy in the clipboard and I go back to Inventor to draw a line from this point to the left, which will be the axis for the left extension, with a contour. I'll show you here, only external, only this, yes, to the center here. Let's create this contour line, this point to this, the clearance, the other diameter, we go here and we close contour. Well, this diameter is for the pipe thread. Dimension is paste. Yes? Control V is the result. Good. Everything is scaled with this center. The procedure is specific. The other dimensions are this 27, 3, and the diameter of 25. You remember? Okay. 25 is the diameter for this clearance. 25. The distance is 27. The clearance is 3. We have to respect diameter of 30 and distance of 55. Diameter of 30 and the distance from here of 55. Okay, this is all. 2 dimensions needed. We have to place this line somewhere on the vertical. Yes, you see. Where is it placed? No problem. We see this 50 as the distance dimension from here to the base, not diameter, but not linear diameter, but distance 50. And there is another one which I have no idea which might be. Let me look very careful. For me it seems to be okay. Oh, maybe this line is not on the same vertical and I can, yes, this is, I create coincidence with this. Now it's fully constrained. Finish sketch, revolve. I can press R, the key R, and I see everything with join, not cut, join. OK. The other revolution feature is in the same plane with this one, but in the other direction. Diameter of 80, thickness of 10, distance of 110 from the end of the left one, and diameter of 30, like here. We respect these dimensions, starting with a sketch in this plane, F7 to see inside, another line at another level with a contour for a flange. Close, and this line is center line. 80 is this diameter, 10 the thickness, 30 the other diameter, 110 from this. Distance of 70, not linear diameter, but the distance. OK, finish sketch, revolve. OK. Next is the hollow in this right side. Same procedure. Let's take a look here. You see diameter of 15, diameter of 40, 2 millimeters here, and that's all. We start by selecting the midpoint. We go to the left on the horizontal, but not to the center, to know that we are not connected to the center line, vertical center line, and then so, and the last connection line is this one. OK, this is center line, and we have to constrain with coincident this line with this point. I forgot that this, oh no, I didn't forget. This point is in the middle. I don't have to place a dimension from for the altitude of this line. 2 millimeters here. To 40 to the right, and 15 internal. Finish sketch, revolve, cut, OK. Now we have the part mostly finished. We have to add some not so important elements. For instance, let's apply the fillet here. Yes, thread, Next is applying the thread here, thread on this diameter, and this is an approximation because we want to select ISO pipe threads, which is gauge 3/4. Yes, the fillet is to the right, of course. Okay, the fillet is present here. Good. Let's apply the chamfers. 3 places. Yes, you remember? Up, middle, down. No other one. Then we'll apply fillets. 45 degrees. This one, 1 millimeter, not 2. This one and this one. Okay. Radius of fillets, 4 millimeters, 4, 4, and 4. Yes, all of them are to be filleted. This is with a radius of 4. Also this and this. That's all. No. Now that's all. Okay. Holes. We have to apply holes. As you can see, 4 holes here and 4 in the basement. Diameter of 10, 4 holes. Diameter of 10, also 4. Let's start with this one. I select this and I finish the sketch. Hole of kind no threaded all the way. Then I select 1 point and I write 10, and then all the other 3 with the same diameter. Okay. For this face, I select the face, I place a point somewhere in the air on the same vertical with the center, and then the diameter is 60, so I place here 60 divided by 2. Because we don't calculate by head. And the hole is the same diameter but not through. You see what happened to this face only. Okay. Then we apply circular pattern for this feature around this axis with 4 holes. Okay, this is the model, my friends. Let's apply material, which is steel carbon, still cast. This is now select faces to be machined. Some faces. The drawing must have all this mentioned, but we don't have this, so I apply to this, still polished. Okay, the data are founded by me. They are here, 1.4 kilograms. That's all for the moment. Bye bye.